All right, this is projectile motion with angles. Ultimately, what we're trying to solve here is a problem involving, for example, a soccer ball that's kicked at an angle. So imagine that it's sent out in this direction with a initial velocity, and there is some angle here with the horizontal ground. And mostly want to figure out two things about this. How long does it take to do this path across here, and how far does it go horizontally? And it's combining something we learned previously. Two things that we've learned previously is our projectile motion with vertical and horizontal equations. And what we learned last time. So if you haven't, if you missed this one, vector components, make sure you go back. Very simple, but not something I'm going to go into this time. So, but we will use it. So let's just jump right into a problem. It says a soccer ball is kicked with an initial velocity of 11 meters per second at an angle of 30 degrees. So I like to draw a picture of what this looks like. It's very similar to what we just saw there. So here's the soccer ball. It's going to be kicked. This is a vector, represents the velocity, the initial velocity of the soccer ball, and it will proceed like this. This is the trajectory, and it will land about right here. The angle at which it was kicked, the angle of its velocity is 30 degrees. And so we have this broken down into a couple of questions. So first thing, this is from the last lesson. Let me just do this over here. If this is the initial velocity vector, we have to uh, get the components of this velocity, this initial velocity, into a horizontal component Vx and a vertical component Vy naught. That's the initial vertical velocity and the horizontal velocity of the soccer ball. So the equations for part A, what is Vx? Vx is equal to V naught cosine theta. So V naught is 11, cosine 30. Part B, well, of course we need to put that in the calculator. I was trying to avoid doing that right now because I need to get my calculator. You should practice along with me. You should grab your calculator, make sure it's set to degree mode. Degree mode. And so we'll type 11 cosine 30, and I get Vx is equal to 9.52 meters per second. Part B is Vy naught is equal to V naught sine theta. Very similar to this, except it has sine. So we'll type in 11 sine 30. Comes out to 5.5 meters per second. So, just a little bit of concept here. So, although the soccer ball is kicked at 11 meters per second at an angle of 30 degrees, essentially what we're doing is it's getting an initial vertical velocity of 5.5 meters per second. Now, that velocity, not Vy naught, but its vertical velocity will decrease until it reaches the highest point, and then it'll start to increase pushing down or moving down, I should say, um, on this way back down. Vx, on the other hand, is just constant velocity. If there is a sunny day and the soccer ball had a shadow, its shadow is traveling at a constant velocity. That's part A and part B. Outer part C. Now we need our two lists, x naught x, vxt, y naught y, vy naught, vy, at. Okay. X naught is usually 0. It's the starting point of the soccer ball. X will be how far it travels horizontally, which we don't know. We know Vx is 9.52 meters per second. We're going to put in Vy naught is 5.5 meters per second. Now, the initial height of the soccer ball should seem obvious that is 0. The final height, or the height later, at the end of that trajectory, should also be 0. A is negative 10. And for part C, they're asking how much time. So we want to solve for t. Now, look at your lists. There's only one equation for the horizontal, and I'll show you. It's right here. You need 3 numbers in order for you to solve for the fourth one, but we do not have 3 numbers, we only have 2, so we're going to skip that for now. It really lies in the vertical list. We're going to find time. Check your equations. We need an equation with t. It must be missing Vy. So this equation has t, this one has t, but it needs to be missing Vy. Well, it's not. That one's not. So we can't use the first one, we must use the second one. Let's do this in another color. I don't know what color. Let's see. Okay, we'll substitute. We don't know t, leave it as t. 1/2 negative 10 t squared. 0 equals 5.5 t plus, let's just call this negative 5 t squared. Let's add 5t squared to both sides. Okay. Let's divide t on both sides. Crosses out that t, crosses out just one of those t's. We're left with 5t equals 5.5. Divide by 5. T is equal to 5.5 divided by 5, which is 1.1 seconds. Cool. That is the time for both lists. The time it takes for the ball to get here is also the time it takes for the ball to get there. So it's 1.1 seconds. And sorry, that was for part C. Part D says, how far did the soccer ball travel horizontally? So in other words, we want to know what is x. Well, we have an equation for x. That's going to involve our horizontal list. X equals x naught plus bxt. Do it down here. That was part, sorry, that was part C. So let's do part D, I believe, yeah. We'll do x equals x naught plus bxt. X is unknown. X naught is 0. Vx is 9.52. And the time is 1.1 seconds. 9.52 times 1.1 seconds is 10 point. You can just say call it 10.5 really. 10.47, doesn't matter. Too much there. That's how far it travels horizontally. That's it. That's projectile motion with angles. So, I mean, the basic part here is we've done C and D many times by now. Um, the part we just have to do at the beginning is A and B, which was our previous lesson right here. That's it.